Good morning, students. Let's begin our class by a small prayer. Thank you. So, how are you? I hope you all are fine and safe at home. So, what about your online classes? Okay, I am very happy to hear that you are doing well. Very good. So, students, we are dealing with the chapter 3, redox reactions and rate of the chemical reaction. Isn't it? So, students, we know that a wide variety of chemical reactions takes place in our daily life. Can you give some examples for some chemical reactions? Yes, very good. Burning of firewood, bursting of crackers, rusting of iron are some examples for this chemical reactions. Very good. So, I have a small question for you. Do all these reactions occur at the same rate? What do you think? No, isn't it? Yes. Sometimes we wish to reduce the rate of rusting of iron, and sometimes we also wish to increase the rate of burning of firewood, isn't it? Can you suggest some method to make the firewood to burn faster? Yes, good. So by reducing the size of the firewood, by providing more air and burning the firewood after drying it, yes, these are some methods that can increase the rate of burning of firewood, isn't it? Very good. So this indicates that there are some factors that influence the rate of the reaction, isn't it? So students, today we are going to learn the factors that influence the rate of the chemical reactions. So are you ready? Yes. So let's move on to the activity. So now students, let us move on to the first activity. So in this activity, we are going to observe the video of reaction of zinc and magnesium with dilute hydrochloric acid. Okay. So in this reaction, you have to observe the test tube in which the reaction takes place in a faster rate. Okay. So here is the experiment. So in this experiment, we have to take two test tubes containing 5 ml of dilute hydrochloric acid. So add zinc metal in one of the test tube and magnesium metal in the other test tube. Observe what happens when we add zinc and magnesium in both test tubes. So after that, in order to find out the gas evolved during this reaction, show a burning matchstick at the mouth of the test tube. Observe what happens here. Okay, good. So I hope that you have clearly observed this video. So here are some discussion tips for you. So you have to answer all the questions and not in your science diary. Okay, so after that you have to present it before the class. Okay, so are you ready? Very good. So here are the discussion tips for you. Have you discussed all the questions? Yes. So you have noted down the answers in the science diary, isn't it? Okay, let us check whether your answers are correct or not. Okay. So, what was the first question? Okay, what are the materials required for this reaction? Isn't it? So, what is your answer? What are the materials that we need to perform this experiment? Yes, we need two test tubes, then dilute hydrochloric acid, zinc metal and magnesium metal. Isn't it? Okay, good. So, what is the second question? Okay, is it necessary to use zinc and magnesium metal of almost same size? So, what do you think? Is it necessary to use zinc and magnesium metal of almost same size? Yes, isn't it? We have to use zinc and magnesium metal of almost same size, isn't it? Otherwise, it will affect the accuracy of our result, isn't it? Okay, good. So, what is the third question? Note down the procedure for this experiment. Okay, so what is the procedure for this experiment? Okay, you have explained it well. Good. So take 2 test tubes containing 5 ml of dilute hydrochloric acid. Then add zinc metal in one of the test tube and magnesium metal in the other test tube. Then observe in which test tube the reaction takes place in a faster rate. Okay, good. So, in order to find out the gas that is evolved from during this experiment, we have to show a burning matchstick at the mouth of the test tube, isn't it? Okay, very good. You have explained the reaction in a very good manner. Okay, so students, what is the fourth question? Okay, which gas is formed during this reaction, isn't it? So, which is the gas formed during this reaction? Yes, it is hydrogen. So, how did you know it is hydrogen? Okay, good. So, you have observed this experiment very well. Good. So, when we show a burning matchstick at the mouth of the test tube, the gas burns with a pop sound, isn't it? So, this indicates that the gas evolved during this reaction is actually which gas? Yes, it is hydrogen. Okay, good. So, now let's move on to the fifth question. So, what is the fifth question? Okay, so write down the chemical equation for this experiment. Okay, so let's take the reaction between zinc and dilute hydrochloric acid. Okay, so what are the reactants here? Okay, good. Zinc and dilute hydrochloric acid. And what is the product obtained during this reaction? Yes, zinc chloride and hydrogen gas, isn't it? So, how we can formulate this chemical equation? Okay, zinc plus hydrochloric acid gives zinc chloride plus hydrogen, isn't it? That is Zn plus HCl gives ZnCl2 plus H2. So, is this a balanced equation? No. So, how we can balance this equation? Yes, by adding 2 in front of HCl, isn't it? Okay, good. So, what is the balanced equation? Yes, Zn plus 2HCl gives ZnCl2 plus H2. Okay, good. So, what is the next reaction? Magnesium and dilute hydrochloric acid, isn't it? The reaction between magnesium and dilute hydrochloric acid. Okay, so what are the reactants for this reaction? Yes, magnesium and hydrochloric acid. And what are the products obtained during this reaction? Okay, it is magnesium chloride and hydrogen gas. Very good. So, how we can formulate the chemical equation for this reaction? Good. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen, isn't it? Very good. So, how we can write in the chemical formula? Yes, Mg plus HCl gives MgCl2 plus H2. So, is this a balanced equation? No, isn't it? So, how we can balance this equation? Yes, very good. By adding 2 in front of the HCl. So, what is the balanced equation? Yes, Mg plus 2HCl gives MgCl2 plus H2. Isn't it? Very good. So now students, let's move on to the next question. Is there any difference in the concentration of hydrochloric acid used in this reaction? So, what do you think? Is there any difference in the concentration of hydrochloric acid used in this reaction? No, isn't it? The dilute hydrochloric acid of same concentration is used throughout this reaction, isn't it? Okay, good. So, what is the next question? In which test tube the reaction takes place in a faster rate? Okay, so in which test tube did you observe the reaction in a faster rate? Very good. The test tube in which we have taken this magnesium and hydrochloric acid, isn't it? Okay, good. So, what is the factor that influences the rate of the reaction? Very good. The nature of the reactant used in this reaction, isn't it? Good. So my dear students, let us conclude this activity. So what we can conclude from this activity? Yes, one of the factors that influence the rate of the reaction is the nature of the reactant that we are using in this reaction. Isn't it? Good. So, I have another question. Is the nature of the reactant is the only factor that influences the rate of the reaction? What do you think? Let us check. So now students, let us move on to the second activity. So in this activity, we are going to observe the video of reaction of magnesium with concentrated and dilute hydrochloric acid. Okay. So here is the experiment. So in this experiment, you have to observe in which test tube the reaction takes place in a faster rate. Okay, so are you ready? Okay, very good. So here is the experiment. So in this experiment, we have to take two test tubes. One test tube containing concentrated hydrochloric acid, that is 6 molar hydrochloric acid, and the other test tube containing 0.1 molar hydrochloric acid. Okay, and in these two test tubes we have to add equal mass of magnesium ribbon. Okay, so observe what happens here. Okay, very good. So students, I hope that you have clearly observed this video, isn't it? Okay, very good. So now let us move on to some discussions based on this video. So here are the discussion tips for you. So students, you have to discuss these questions and find out the answers. You have to note these answers in the science diary, okay? And after that, you have to present before the class. Okay. So here are the discussion tips. So now students, I hope that you have discussed the questions. So let us check whether your answers are correct or not. Okay. So what is the first question? Okay, is it necessary to use magnesium ribbon of equal mass? Okay, so what do you think? Is it necessary to use magnesium ribbon of equal mass? Yes, isn't it? We have to use magnesium ribbon of equal mass. Otherwise, it may affect the accuracy of our result. Isn't it? Okay. So, what is the second question? What about the volume of HCl? So, what is your answer? Yes, we have to use equal volume of HCl. Isn't it? Very good. So, now what is the third question? Okay, write the balanced chemical equation for this reaction. Okay, so what are the reactants used in this reaction? Magnesium and hydrochloric acid. Okay, So what are the products obtained during this reaction? Yes, magnesium chloride and hydrogen gas, isn't it? Very good. So how we can write the balanced chemical equation? Yes, Mg plus 2HCl gives MgCl2 plus H2, isn't it? Very good. So what is the next question? Yes, in which test tube more number of HCl molecules are present, isn't it? So in which test tube more number of hydrochloric acid molecules are present? Yes, the test tube containing concentrated hydrochloric acid, isn't it? Okay, so now what is the next question? Okay, so in which test tube the reaction takes place in a faster rate? So, in which test tube the reaction takes place in a faster rate? What do you have observed in the experiment? Yes, the test tube in which magnesium and concentrated hydrochloric acid is taken, isn't it? Very good. Okay, so what is the last question? Yes, what is the relationship between concentration and rate of the reaction? Okay, so what is the answer? Yes, as the concentration of the reactant increases, the rate of the reaction also increases, isn't it? Okay, very good. So now students, what we can conclude from this experiment? Yes, we can conclude that as the concentration of the reactant molecule increases, the number of reactant molecules per unit volume increases. As a result, the number of collisions between the reactant molecule increases, and this results in the increase in the rate of the reaction, isn't it? Okay, very good. So now students, here is a small question for you. So this is the chemical reaction between marble and dilute hydrochloric acid. Okay, CaCO3 plus 2HCl gives CaCl2 plus H2O plus CO2. So the first question is, which is the gas formed during this reaction? Suggest a method to identify this gas. And second question is, how we can improve or increase the rate of this chemical reaction? So, what is your answer? Okay, so the answer for the first question, that is, which gas is formed during this reaction, and suggest a method to identify this gas. Okay, so what is your answer? Yes, carbon dioxide is formed during this reaction, and by passing carbon dioxide gas through lime water, the lime water turns milky, isn't it? Yes, by this method we can identify the presence of carbon dioxide gas. Very good. So, what is the answer for the second question? Suggest a method to increase the rate of the reaction. Yes, by increasing the concentration of the hydrochloric acid, we can increase the rate of the reaction, isn't it? Okay, very good. So now students, here is a small activity for you. If magnesium, zinc, dilute hydrochloric acid, concentrated hydrochloric acid are provided for you, then design an experiment in order to produce hydrogen gas in a faster rate. Okay, so you have to find out the answer for this question and note in your science diary. Okay, next day we can discuss the answer for this question. Okay, so I hope that this class was very useful for you. Thank you and have a nice day.